Hello YouTube friends, my name is Aras and welcome to your channel. In this video, we're going to be looking into the paper 11 of May-June 2020. First, let's see the syllabus. There are 8 topics and this table provides us the weight of every one of them. We can clearly see that the quadratics, series and differentiation were the main focus. That in mind, let's have the first problem. The sum of the first 9 terms of an arithmetic progression is 117. The sum of the next 4 terms is 91. Find the first term and the common difference of the progression. The problem mentioned that this is an arithmetic progression, so it's a good idea to check out the MF19 formula sheet to find the exact formula of arithmetic progression. Alright, now that we have located the formula for the arithmetic series, let's try to write that down on our own paper. If we read the first sentence again, it says that first 9 terms is 117, which means S of 9 is equal to 117. Now that we have translated the problem into mathematical equation, we just need to expand that S9 by using the formula that we have found from MF19, which means instead of n, we have to input 9. We can simplify the equation by multiplying the both sides of the equation by the reciprocal of 9 over 2. If we do so, we get 2a plus 8d equal to 26. We can divide everything by 2, which leaves us with a plus 4d equal to 13. We can also rearrange this now to find a, which would equal to 13 minus 4d. We can't continue anymore. We have found one equation and there are 2 variables in it, unless if we continue reading the problem and get more information from it. So let's try to read the second sentence of the problem, which says, the sum of the next 4 terms is 91. From the first part of the problem, we had S9, which is the addition of N1 up to N9. Now we are adding 4 more terms into it, which is going to be giving us S13, which equals to N1 up to N13. In other words, S13 would equal to S9 added up by the next 4 terms, which is equal to 91. So we can say S9 plus 91 would equal to S13. Now we already know the value of S9, which is 117. We just have to add that with 91 to get 208 as of the value for S13. What we found is S13 is 208. And all we need to do right now is that use the same formula again and instead of n, just input the 13 into it. To simplify the equation a bit further, we can multiply the both sides of the equation by the reciprocal of 13 over 2. Which will lead us to 2a plus 12d equal to 32. And by dividing by 2, the equation will lead to a plus 6d equal to 16. And this could be our second equation. Now that we have 2 different equations, we can solve them simultaneously by substituting the first one into the second one and working out in order to find d. If we do so, we get 13 minus 4d plus 6d would equal to 16. And that gives us 2d equaling to 3. And by dividing the both sides by 2, d would equal to 3 over 2, which is equal to 1.5. Now that we have d, we can go back and return to the first equation and input the value of d in order to find a. By doing the calculation, we can easily find out that a would equal to 7. In conclusion, a equals to 7 and d is equal to 1.5, and those are the ones that the problem was asking us to find. Okay, in problem 2 it says the coefficient of reciprocal of x in the expansion of addition of 2 binomials is 74, and it is asking us to find the value of the positive constant k. So the first thing to do here is, let's try to go back to MF19 formula sheet and remind ourselves with the formula of the binomial series. There it is. Now that we have it, let's try to write it down on our paper. Now at this point, by using the formula that we have at hand, we have to expand each one of these 2 binomials in order to find the term which is going to be involving the reciprocal of x in it. To do so, we have 2 different methods. One of them is doing it mentally. In order to do it mentally, you have to have a really good imagination and you should have practiced it quite a lot to get the hang of it. The second method is expand it until you reach the answer. Here, since we have the time, I will give you the full expansion of each one of these binomials so that we can see how they're going to be looking like. If we do use the second method in order to expand and find the answer, we should not expand it wholly, and whenever we find the answer, we should stop there and not continue. And after finding the answer, you should simplify each one of them separately in order to find the coefficient of reciprocal of x. In the first binomial, the term which has 5 of 3 is going to be the one that has reciprocal of x in it. In order to find the value of 5 of 3, we can always use the button of NCR on our calculator to find the value of that. Then we have to give the power of 2 to the kx and also the power of 3 to the reciprocal of x. Then if we do simplify it, we can easily see that the 10k squared is going to be the coefficient of 1 over x in this binomial. Now on to the second binomial, we can easily see that the second term, which is 8 of 1, is going to be providing us with the reciprocal of x in it. And we can only stop there and do not write down the rest of them, it's not needed. Now all we need to do now is that we have to simplify the term which has 8, 1 in it. Now, again, we can use the NCR function on our calculator and put the 8 before the n and put 1 after the n in order to find the value of it, which is going to be 8. And 1 raised to the power of 7, that is going to equal to 1, and then that's going to get multiplied into negative 2 over x. And in total it will equal to negative 16, that's going to be the coefficient of reciprocal of x in the second binomial. Now let's not forget that those two binomials were being added, so we have to add up these two coefficients of reciprocal of x's and make it equal to 74, which the problem told us that they are equal to 74. So from that we get 10k squared minus 16 equal to 74. Now in order to cancel the negative 16, we can add up positive 16 to the both sides of the equation, so we get 10k squared equal to 90. And dividing the both sides by 10 will give us k squared equal to 9. Square rooting the both sides will give us k equal to positive and negative 3. Since the problem told us to find the positive constant k, so we can say that k equals to 3. Problem 3 goes like this. Each year the selling price of a diamond necklace increases by 5% of the price the year before. The selling price of the necklace in the year 2000 was $36,000. In part A of the problem, it asks us to write down an expression for the selling price of the necklace n years later and hence find the selling price in year 2008. It seems like that it's the best idea to make a table and try to find a pattern how the price of the necklace will be changed every year. Now we know that in the year of 2000 the price of the necklace is $36,000. And the next year in 2001 the price will increase 5%. So 36,000 is going to be multiplied by 1.05, which is going to equal to $37,800. And if we're trying to find the price of the necklace in the year of 2002, we have to multiply $37,800 by the same increase, which is 1.05, which is going to give us $39,690. From which we can easily understand that for the next upcoming year, we just have to multiply the new amount by 1.05. And in total, we can say in n years later, we were going to be having this equation of $36,000, which is the initial price of the necklace, which is going to get multiplied by 1.05, having the power of n depending on how many years is going to be considered. By having the formula, now we can easily find the price of the necklace in the year of 2008. All we need to do is, instead of n, we have to input 8. If we do so, we get the price equal to $53,188. And we can write that down within the three significant figures, which is going to be equal to $53,200. In part B of problem 3, it says, the company that makes the necklace only sells one each year. Find the total amount of money obtained in the 10-year period starting in the year 2000. This problem is the sum of geometric progression. So let's try to go to MF19 formula sheet and find the formula for that. There it is. Now that we have found it, let's write it down on our own paper. Now in this formula, A is going to be the initial value, which was $36,000, which we dealt with in problem part A, and R is the common ratio, which we found it equaling to 1.05. And since we're trying to find it within the period of 10 years, N is going to be 10. Now by using the known information and data and putting them into the formulae, by using the calculator, we can find the final result of the problem, which equals to $452,804 in total. If we do write that down within 3 significant figures, we get $453,000 in total. Okay, the problem 3 has given us a figure, and it says that the diagram shows the graph of y equaling to f of x, where f of x is equaling to 3/2 cosine 2x plus half, for x being between 0 and pi. In part A, it is asking us to find the range of the function f. In this part of the problem, the figure is not that helpful. It just gives us an idea how the range is. Now, we can start from what we already know. We know that the range of cosine x is between -1 and +1. Then from that, we can start constructing the function of f of x. First, let's try to deal with the angle. We know that the angle of cosine or sine, any of the trigonometry functions, they're just going to change the period and they're not going to be affecting the range. So cosine 2x, still it will have the range of between -1 and +1. Then we can see that in the function of f of x, cosine 2x is being multiplied by 3/2. So let's do that to our inequality. If we multiply the inequality by 3/2, the 3/2 cosine 2x would be between -3/2 and +3/2. And at the end, we just need to add half. And if we do so, we find that the range of f of x is between -1 and +2. In part B of problem 4, it says there is a function g such as that g of x equals to f of x plus k, where k is a positive constant. The x-axis is a tangent to the curve y equaling to g of x. State the value of k and hence describe fully the transformation that maps the curve y equaling to f of x onto the y equaling to g of x. Well, in part A of the problem, we found the range of the function f of x. If we are trying to change that f of x and make it being tangent to the x-axis, we know that the minimum value of the f of x is -1. That means we have to shift the graph by +1, which states that k would be equaling to +1, so that the new graph of g of x would be tangent to the x-axis. Now this shifting the graph 1 towards up is a translation, which is a translation by the vector 0, 1 parallel to the y-axis. In problem 5, there are 2 equations given to us, and it says that given that the line is a tangent to the curve, express m in terms of c. Since we're trying to find the intersection points, it's a good idea to substitute one of them into the other one and make it into a standard form of a quadratic. In this problem, it's better to input the line into the curve, which is going to be way more easier. And if we do that, we get x multiplied into the line equaling to 16. That's what we get after substituting. Then we can distribute the x, which is going to give us mx squared plus cx equaling to 16. Pushing the 16 to the other side of the equation will make the quadratic in its standard form. The problem mentioned that these two are tangent. That means the discriminant is equaling to 0. So b squared minus 4ac is going to equal to 0. All we need to do is now get the ABCs from the standard form of the quadratic and plug them into this discriminant. And if we do so, we get c squared minus 4m multiplied by -16 equaling to 0. If we do simplify it, we get c squared plus 64m equaling to 0. we can push the c squared to the other side of the equation, which is going to give us 64m equal to negative c squared. Dividing the both sides by 64 will give us m equal to negative 1 over 64 multiplied by c squared. In part B of problem 5, they have given us that m equals to negative 4 and they ask us to find the set of values of c for which the line intersects the curve at two distinct points. Well, this problem will look like almost the same as of part A, but the only difference is we have a value for m and the discriminant is going to be greater than 0 because we have to find two distinct points for it. So let's try to do the same. Let's substitute the line into the curve, which is going to give us x multiplied by the line equal to 16. If we do distribute, we get negative 4x squared plus cx equal to 16. We can push the 16 to the other side of the equation to find the standard form of the quadratic, that is negative 4x squared plus cx minus 16. Since we are after finding two distinct points, that means the discriminant is greater than 0. So b squared minus 4ac is greater than 0. By getting the ABCs from the standard quadratic, we can simplify it into c squared minus 256 is going to be greater than 0. We can push the negative 256 to the other side of the inequality to get c squared greater than 256. By square rooting the inequality, we can find the answers, which are c greater than 16 and also c is being less than negative 16. In problem 6, functions f and g are given and in them a and b are constants. In part A of the problem it says, given that the composite function of g of 2 is equal to 10 and inverse of f of 2 is equal to 14, find the values of a and b. Let's start it off with the first given information, which is the composite function of g of 2 is equal to 10. We know that the g of x is equal to 3x plus b, and in order to solve for the composite function, it's a good idea to start from within the composite, so we have to find g of 2. So let's input that 2 into the function of g. So g of 2 would equal to 3 times 2 plus b. If we simplify it, g of 2 would equal to 6 plus b. Now that we have found the g of 2, we can write down the composite function as of g of 6 plus b equaling to 10. Now all we need to do is go back to the g of x and input 6 plus b instead of the x. And if we do, we get 3 times of the x, now that x is 6 plus b, added up by another b equals to 10. Now if we distribute the 3 inside the bracket, we get 18 plus 3b plus b equaling to 10. We can add up those b's, which is going to be giving us 4b, and push the 18 to the other side of the equation. Now in total that leaves us with 4b equaling to negative 8. Dividing the both sides by 4, b would be equaling to negative 2. We were able to find the value of b by just using the first given information. Now let's try to check the second information that's given. It says the inverse of f of 2 is equal to 14. We know that we have the function of f of x, but we don't have the inverse. We have to find the inverse first. In order to do that, we have to go through 3 steps. The first one is, instead of f of x, let's try to write it down as of y. So we get y equal to half x minus a. Second step being, we have to swap the x and y's. So instead of y, I should write down x, and instead of all of the x's, I have to write down y. So the equation will be changing into x equal to half y minus a. Now into the third step, I have to rearrange it and express y within the terms of x. In order to do that, first let's try to push that negative a to the other side of the equation. We get x plus a equal to half y. Then I have to multiply the equation by 2 in order to find the y. And if I do that, I will be getting y equal to 2x plus 2a. Now that y is standing for inverse of f of x. So I can write it down as of inverse of f of x is equal to 2x plus 2a. Now that I have built what I needed, let's try to double check the given information. Inverse of f of 2 is 14. Okay. Now I just need to input 2 into the inverse of f of x. which is going to be 2 times 2 plus 2a equaling to 14. Simplifying that gives us 4 plus 2a equaling to 14. Now I can simplify it a bit further. 2a would be equaling to 10. Dividing the both sides by 2 leaves us with a equaling to 5. Now in conclusion, our answers are a equals to 5 and b equals to -2. In part B of problem 6, it says using these values of a and b, find an expression of g of f of x in the form of cx plus d, where c and d are the constants. Since we have found the values for a and b, let's try to rewrite the functions of f and g separately. So g of x would equal to 3x minus 2, and f of x would equal to half x minus 5. Now that we have the functions, we just need to make a composite function out of them. We have to input the f of x into the g of x, which is going to be g of half x minus 5. Now g of half x minus 5 is equal to 3 times of half x minus 5 and then subtracted by 2. So in total, the composite function of g of f(x) is going to equal to 3 half x minus 15 minus 2 after distributing the 3. If we simplify that, the composite of g of f of x is going to equal to 3 half x minus 17, which is the final answer of the problem. In part A of problem 7, there is an identity that we have to prove. In all of the identity problems, we should always start from the left side or the right side. And we'd rather to start from the side which is more complicated or it has more terms. In this specific problem, we can see the left side has 2 terms and it is looking like more complicated. So let's start with the left-hand side and rewrite it. In the left-hand side, we have 2 different fractions. So let's go with the common denominator. In order to do that, we have to somehow multiply the first fraction with the second denominator and the second fraction with the first denominator. And if we just do that, we get 1 plus sine theta having the power of 2 added up with cosine squared theta over cosine theta multiplied into 1 plus sine theta. Then we could expand the binomial of 1 plus sine theta. That's going to give us 1 plus 2 sine theta plus sine squared theta added up by cosine squared theta over the same denominator. We had an identity which is sine squared added up with cosine squared is equal to 1. So we can, instead of those two, we can write it down being 1. And if we do so, we get 1 plus 2 sine theta added up by 1 over the same denominator. Then adding 1 plus 1 is going to give us 2 plus 2 sine theta over cosine theta multiplied by 1 plus sine theta. Within the numerator, we can factorize each one of the terms by 2, and if we do, we get 2 times 1 plus sine theta over cosine theta multiplied by 1 plus sine theta. We can see that the 1 plus sine theta is being repeated onto the numerator and the denominator, and they could be cancelled. If we do that, left-hand side would equal to 2 over cosine theta, and that was the right-hand side. So we can say the left-hand side is equal to the right-hand side, and that's how we prove the identity. In part B of problem 7, there is an equation given to us, and the left side of the equation of the same identity that we had in part A, and that equals to 3 over sine theta. And we have to solve that for theta being between 0 and 2 pi. We already proved the identity, so instead of the addition of those 2 fractions, we can use the right-hand side of the identity and change the addition of those 2 fractions into 2 over cosine theta and make that equal to 3 over sine theta. Now this is the equation that we need to solve now. By cross-multiplying this equation, we can see that sine theta over cosine theta would equal to 3 half. Now we have an identity for sine over cosine, which is tangent. So tangent theta is equal to 3 half. If we do inverse it, theta would equal to inverse of tangent of the angle 3 over 2. At this point, we just to be have to be very careful because the domain given to us is within the unit of radians. So if you're trying to plug this inverse of tangent into the calculator, first we have to put the unit of the calculator into the radians. And afterwards, if we do that, we get theta equivalent to 0.983. Now that's the basic angle, and it is one of the solutions. Now in order to find the rest of them within the domain, we have to go back and check out the circle. Now within the circle and those four quadrants, we can find that tangent is being positive in the third quadrant. And in order to get the next solution within the 0 and 2 pi, we have to say pi plus the basic angle will give us the answer within the third quadrant. So theta would equal to pi plus 0.983 as of our second solution, which equals to 4.12. And it has the unit of radians. All in all, we have two solutions for this problem. One of them is 0.983 and the other one is 4.12. Those are going to be the final solutions of the problem. Problem 8. In the diagram, ABC is a semicircle with diameter AC, center O, and the radius is 6 centimeters. The length of the arc AB is 15 centimeters. The point X lies on the AC and BX is perpendicular to AX. And it is asking us to find the perimeter of the shaded region BXC. Going back to the MF19 formula sheet, we know that the formula of arc length is equaling to R multiplied by theta. But I have to remind you that the theta here must be in the unit of radians. Since the arc length of AB is given to us 15 centimeters, we can say that that equals to R theta, which leads us to 15 equaling to 6 times of the angle AOB, and that angle is going to be within the unit of radians. We can divide the both sides by 6, which is going to give us the angle of AOB equaling to 2.5 radians. Since AC is a diameter and it is a line, it has the angle of pi. So we can find the angle of BOC by just subtracting 2.5 from pi. So the angle of BOC would equal to pi minus 2.5, which equals to 0.642 radian. And now that we have found the angle of BOC within the unit of radians, we can easily use the formula of the arc length equaling to R theta again in order to find the length of BC, which equals to 6 multiplied by 0.642. That is equaling to 3.85 centimeters. So far, we have just found one side of the shaded region. Now, in order to find the BX, since OBX is a right-angled triangle, we can also use the trigonometry functions in order to be able to find the length of BX. Now, we know that the sine of the angle BOX would be opposite over hypotenuse. Now the opposite being bx and the hypotenuse is a radius, so that's going to be 6. So all in all, we can say sine of 0.642 would equal to bx over 6. By just cross multiplying, we can easily find the value of bx, that equals to 3.59 centimeters. Within the same right angle triangle again, we can use the cosine in order to find the value and the length of OX. Cosine being adjacent over hypotenuse, adjacent is OX, and the hypotenuse is 6. So cosine of 0.642 would equal to OX over 6. By just cross multiplying, we can find the value of OX equaling to 4.81 centimeters in total. OX is not the length that we should be finding. We should be finding CX. But we can use OX and subtract that from the radius, and OC is a radius. If we subtract the OX from the radius, we would be able to find the CX. So we can say CX is equal to radius minus OX, which is 6 minus 4.81, and CX would equal to 1.19 centimeters. Now that we have found the length of each one of those sides separately, we just need to add them up in order to find the perimeter of the shaded region BXC. Now BX plus BC plus CX, that's going to give us the perimeter, which is equal to 8.63 centimeters in total. Problem 9 is giving us the equation of a curve, and in part A it is asking us to find expressions for the first and the second derivative. We have a binomial in the curve. In order to do the differentiation of a binomial, we have to do and multiply three things. One of them is the power, multiplied by differentiation of inside the bracket, and then multiplied by the same binomial but reduce the power by 1. So let's do that. The power is 3, so 3 is going to be getting multiplied into the differentiation of inside the bracket, which is going to be negative 2. So 3 multiplied by negative 2 multiplied by the same binomial, but the power is going to be reduced by 1, so the power is going to be 2. Now the second term is just 24x. The differentiation of that is going to be 24. So at the end, we will be adding 24 to it. Now let's get back and simplify the binomial part. 3 times negative 2 is going to give us negative 6. So in total, we're going to be getting negative 6 multiplied by 3 minus 2x having the power of 2 added up with 24. That's going to be our first derivative. In order to find the second derivative, we have to differentiate the first derivative. Now again, we have to go through the same 3 steps in order to do the differentiation of the binomial. The power is going to be brought down, so the negative 6 is going to be multiplied by 2, and then it will be multiplied by differentiation of inside the bracket, which is negative 2, and then it will be multiplied by the same binomial, but the power is going to be reduced by 1. 2 minus 1 is just going to be left up with 1. And then we have to add it with the differentiation of 24, which is 0. So in total, if we simplify it, we're going to be getting 24 times 3 minus 2x as of the second derivative. Part B of problem 9 says, find the coordinates of each of the stationary points on the curve. To do that, we have to make the first derivative equal to 0. In part A, we found the first derivative, which was negative 6 times 3 minus 2x having the power of 2 added up with 24. So we have to make that equal to 0. We can push the binomial to the other side of the equation to make it positive. So we would be getting 6 times 3 minus 2x having the power of 2 equal to 24. Then we can divide the both sides by 6. If we do so, the binomial would equal to 4. If we do square root the both sides, we get 3 minus 2x equaling to positive and negative 2. Now we have two equations that we have to deal with. First, let's try to deal with it being positive 2. So 3 minus 2x equaling to positive 2. If we just rearrange it, we can easily find that 2x would equal to positive 1. Dividing the both sides by 2 will leave us with x equaling to half. Now that we have found 1x, we have to find the corresponding y of that. In order to do it, we have to input this x going back to the original equation of the curve given to us. So we will be getting y equaling to 3 minus 2 times half, having the power of 3 added up with 24 multiplied by half. If we simplify it, we get y equaling to 2 cubed added up with 12. Now that means y will be equaling to 8 plus 12. That is going to be y equaling to 20. That means one of the coordinates of the stationary point is going to be, the x of it is going to be half and the y of it is going to be 20. So half 20 is one of the stationary points. In order to find the next stationary point, we have to deal with the second equation that we had. So 3 minus 2x, we have to solve it when it is equal to negative 2. We can rearrange it to find 2x equal to 5. By dividing the both sides by 2, x would equal to 2.5. Now we have to do the same thing as we did previously. By inputting the x equal to 2.5 to the original equation of the curve, we would be able to find the corresponding y of that. If we just go through it and do all of the calculations, we're going to find that y would equal to 52 at the end. So the next point is going to be 2.5 and 52. And that's going to be our second stationary point. In part C of problem 9, it says determine the nature of each of the stationary points. Now, since we found the second derivative in part A, we can benefit from it. All we need to do is plug in the x's of each stationary point into the second derivative and find out if it is going to be positive or negative. If it is going to be positive, that stationary point is going to be a minimum point. But if it is going to be a negative one, that stationary point is going to be a maximum point. Now we had 2 points. Let's try to double check each one of them separately. The first stationary point was half and 20. Let's plug in the x equaling half into the second derivative. So it will be 24 multiplied by 3 minus 2 times half. Now if we simplify it, we get 24 multiplied by 3 minus 1. That is equaling to 24 multiplied by 2, which is going to give us the second derivative is 48. Now because it is positive, we can say the stationary point half and 20 is going to be a minimum point. Now let's try to double check the other stationary point, which was 2.5 and 52. So if x is 2.5, we just need to plug in that into the second derivative, which would be 24 multiplied by 3 minus 2 times 2.5. If we multiply it, we're going to get 24 multiplied into 3 minus 5, which will be equal to 24 multiplied by negative 2, and in total that would be, the second derivative is negative 48. Now because it is a negative value, we can say the stationary point of 2.5 and 52 is going to be a maximum point. In problem 10, the coordinates of the points A and B are given to us, and in part A, it says find the equation of the circle C for which AB is going to be a diameter. If AB is going to be the diameter of that circle, we can average the x and y of those 2 points in order to find the coordinates of the center of the circle. So C equals to negative 1 plus 7, those are the x's, divided by 2. And also, I have to add up the y's, which are negative 2 plus 4, and I have to divide them by 2 to average them out. And in total, we can find the C equaling to 3 and 1. Next, in order to write down the equation of the circle, I need to find out the radius of the circle. Since I have the center and there are 2 points on the circle, that could be easily found by using the radius equation. I choose the coordinates of point B. You can choose A, no problem with that. And I've put it into the equation of the radius in order to find it. So that's going to be 7 minus 3 raised to the power of 2 added up with 4 minus 1 raised to the power of 2. All of that is under the radical. If we do simplify it, we get r equivalent to square root of 4 squared added up with 3 squared. If we simplify it a bit further, we get r equivalent to square root of 16 plus 9, which is r equivalent to square root of 25. And from that, we get r equivalent to 5. Now that we have the coordinates of the center of the circle and the radius, we can easily write down the equation of the circle, which would be x minus 3 raised to the power of 2 added up with y minus 1 raised to the power of 2 equal to r squared, which is 25. In part B of problem 10, it says find the equation of the tangent t to the circle C at the point B. We know that in order to find equation of any line, we need the point and the gradient of that line. Now the point is already given to us, but in order to find the gradient, we know that the gradient of tangent and the gradient of the radius, they are perpendicular. Let's try to find the gradient of the radius first. I'm using the points A and B in order to find the gradient of the radius. We can also use CB or CA. Those are 2 different options too. So m of AB is going to equal to 4 minus negative 2 over 7 minus negative 1, which is equal to 4 plus 2 over 7 plus 1. That equals to 6 over 8. And we get 7 over 4 as of the gradient of the radius. If you want to find the gradient of the tangent line, we just need to flip the 3 over 4 and give a negative to it. So m of t is going to be negative 4 over 3. Now that we have the gradient of the tangent line and a point on it, we can easily write down the equation of it. So we can say that's going to be y minus 4 equaling to gradient, which is negative 4 over 3 multiplied by x minus 7. In order to simplify it, I can multiply the whole equation by 3, which gives us 3y minus 12 equaling to negative 4 multiplied into x minus 7. Distributing the negative 4 inside the bracket will give us negative 4x plus 28. We can rearrange the equation now, which is going to leave us with 3y plus 4x equaling to 28 plus 12. So our final answer is going to be 3y plus 4x equaling to 40, which is going to be representing the equation of the tangent t to the circle C. In part C of problem 10, it says find the equation of the circle, which is the reflection of the circle C in the line T. If we do reflect the circle onto the line T, We know the radius is not going to change, but we just have to find the center of the new circle. If line T is the reflection line, we can easily understand that the point B is going to be the midpoint of between the centers of those two circles. So we can average out the x and y of the centers of the circles and make them equal to the x and y of the point B. From that, we can write down this equation that the average of the x's, which is 3 plus the capital X divided by 2, must equal to the x of the b, which is 7. If I do cross multiply it, I get 3 plus capital letter of x equaling to 14. And if I rearrange it, I get x equaling to 11. I can do the same thing onto the y. 1 plus capital letter of y divided by 2, that's going to equal to the 4, which is the y of point B. If I cross multiply it, I get 1 plus capital letter of y equaling to 8. And we can find the y equaling to 7. Now these capital letters of x and y, they are representing the center of the new circle after being reflected onto the line of T. So far we have found the center of the circle and the radius is not being changed, so we can now write down the equation of the new circle, which is going to be x minus 11 raised to the power of 2 added up with y minus 7 raised to the power of 2 equaling to 25. In problem 11, there's a diagram which shows the part of the curve and a line, and they're intersecting at 2 points of A and B. And the point C lies on the curve, and the tangent to the curve at C is parallel to AB. In part A, it is asking us to find by calculation the coordinates of A, B, and C. For starters, let's try to just find the coordinates of A and B. In order to do that, we have to look at the problem as if this is a quadratic problem and solve for the curve and the line as of a simultaneous problem. We have to substitute one of them into the other one. And the best option is, since the curve is already given to us, let's try to plug that into the equation of the line, which we're going to be getting 2 times of 8 over x plus 2, and then added up with x equaling to 8. Simplifying that will give us 16 over x plus 2 added up with x equaling to 8. If we multiply the whole equation by x plus 2, we get 16 added up with x times x plus 2 equaling to 8 times x plus 2. Distributing the x and the 8 into their corresponding brackets, it's going to give us 16 plus x squared plus 2x equaling to 8x plus 16. Rearranging it and having it as of a standard form of a quadratic, it's going to give us x squared plus 2x minus 8x equaling to 0. That simplifies into x squared minus 6x equaling to 0, and we can factorize them by x, which would be x times x minus 6 equaling to 0. Now from that we can understand that x could be 0 or x minus 6 could be 0. Now we get 2 different answers for x. One of them is going to be x is 0 and the other one is x equaling to 6. Now these x are the x of A and B. We can already see that from the figure that the x of A is 0, and we have mathematically shown that it is equal to 0, and x of B is equal to 6. All we need to do now is plug in these values into the curve or the line, which is completely upon us to choose from, in order to find the corresponding y of each one of those points. Since the equation of the line is way more simple, I would use that in order to find the corresponding y. If I plug in x equaling to 0 into it, I can work it out and find that the y of that would equal to 4. That means the coordinate of A is 0 and 4. Then if I plug in x equaling to 6 into the equation of the line, I get 2y plus 6 equaling 8. By rearranging it, I get 2y equaling to 2. By dividing the both sides by 2, I get y equaling to 1. Now, that means that the coordinate of B is 6 and 1. Now, in order to find the coordinate of C, we have to use the next information provided by the problem itself. It says that the gradient of the AB, it is equaling to the gradient at the point C. So let's try to find the gradient of AB. We can rearrange the equation of the line and make it 2y equaling to 8 minus x. And then we can divide the whole equation by 2 to find y equaling to negative half x plus 4. If I do the differentiation onto this equation now, I can find the gradient of the AB equaling to negative half. Now all I need to do now is find the derivative of the curve and make it equal to -half, because we know that the gradient at point C and the gradient of AB, they are equal. That was given to us by the problem itself. In order to find the derivative of the curve, let's try to write it down in a proper way, which is y equal to 8 times of x plus 2 raised to the power of -1. Now that's going to be a binomial, and we need to find the derivative of that binomial. We have to go through 3 steps. One of them is bring the power down, which is -1, and multiply it into the derivative of inside the bracket, which is going to be 1, and then multiply it into the binomial itself, but the power is going to be reduced by 1, so the power will be turning into -2. If we do simplify it, we can find the derivative of the curve equaling to -8 over x plus 2 raised to the power of 2. Now we have to make this equal to -half. If we do cross multiply it, we get x plus 2 raised to the power of 2, it equals to 16. Square rooting it, it will give us x plus 2 equaling to positive or negative of 4. Now let's try to solve for each one of these separately. If I solve it x plus 2 equaling to positive 4, I can find that x would equal to 2. But on the other hand, if I solve for x plus 2 equaling to -4, I will be finding x equaling to -6. But from the graph, I can see that the x of point C is positive, so I'm going to accept that the x of it is going to be positive 2. And x being -6 is going to be rejected. Now in order to find the coordinates of C, I need to plug in the x equaling 2 into the equation of the curve. Let's not forget that C is on the curve, so I have to plug in the x into the equation of the curve. And if we do that, we get y equaling to 8 over 2 plus 2, which is 8 divided by 4, and we get y equals to 2. So the coordinate of C is going to be 2 and 2. In part B of problem 11, it says, find the volume generated when the shaded region bounded by the curve and the line is rotated through 360 degrees about the x-axis. First, I want to mention that the formulae for the volume is not given in the MF19 formula sheet, so we have to know it by heart. The second thing is that the volume generated by the shaded region, we cannot directly find it by using the formulae. One thing that we can do is that we can find the volume generated underneath the line of AB first, and then find the generated volume underneath the curve between A and B, and then subtract those two volumes in order to find the volume of the shaded region. For the volume of line, I want to write it down as a V of L, which is going to be the integration from 0 till the point B, which has the x of 6, so it's going to be from 0 till 6 pi y squared dx. Now the equation of the line is already given to us. Instead of y, I would rather to put the equation of the line into it, which is going to be -half x plus 4. Now on to the next step. Since pi is a constant value, I can just push it outside the integration, and then I would rather to expand the binomial, which is going to give us 1/4 of x squared minus 4x plus 16. Now if we do integrate it, we get V of L equaling to pi multiplied into, the power is going to be increased and then it will be divided with the new power. So we get 1/4 multiplied by 3 of x cubed. Minus, we have to do the same thing into the second term. We have to add the power by 1, which is going to be 2. Then we have to divide with it. So we get 4x squared divided by 2. And then added up with 16 is just only going to get x in order to be integrated. Now, all of these are going to be between the lower boundary of 0 and 6. If we do simplify within the bracket, we're going to get V of L equaling to pi multiplied into 1/12 of x cubed minus 2x squared plus 16x from lower boundary of 0 up to the upper boundary 6. Since all of the terms inside the bracket are having x in them, inputting 0 into it is just going to turn into 0. So I just have to input 6 into it in order to get the volume of V of L. If I do that, and then by using the calculator, I can find the V of L equaling to 42 pi. Let's try to find V of C, which is going to equal to integration from 0 till 6 of pi y squared. Now instead of y here, I just have to input the equation of the curve. By distributing the power of 2, I'll be getting a squared over x plus 2 squared, Just like before, I can put the 64 pi outside the integration and make the binomial go to the top by the power is going to be -2. Now we can integrate that. We can increase the power of the binomial, which is going to be -1, and I have to divide with it, which is going to be 1 over -1 multiplied into x plus 2 having the power of -1. Again, the lower boundary is going to be 0 and the upper boundary is going to be 6. So v of c is going to equal to the 64 pi multiplied into inputting the upper boundary, which is 6, minus inputting the lower boundary, which is 0. Now, if we put all of that into the calculator, we can find the v of c equal to 24 pi. Now, by subtracting these two volumes, we can find the volume of the shaded region, which is going to be 42 pi minus 24 pi, that equals to 18 pi, which is going to be our final solution to the problem.